What if time itself is shifting beneath our feet? Earth's rotation is speeding up, days are getting shorter, and scientists are scrambling to understand why. Is something strange happening to our planet? Recent studies have revealed that Earth's rotation is speeding up, causing our days to shorten by about 1.3 milliseconds on July 9th and August 5th, 2025. This shift is unusual as Earth's rotation has been slowing down over millions of years. The primary cause is the Moon's gravity, which speeds up Earth's spin when it's closer and slows it down when it's farther away. Seasonal changes, atmospheric dynamics, and climate change also play a role. While this won't noticeably impact daily life, it could affect timekeeping systems. In this video, we'll dive into the science behind this change and its implications. The discovery of Earth's accelerating rotation has caught the attention of scientists. In 2020, researchers first detected that Earth was spinning faster than usual. And by 2024, the planet set a record for the shortest day at 1.66 milliseconds shorter than the standard 24 hours. This was the shortest day ever recorded, which has raised questions about the future behavior of Earth's rotation. While these small time discrepancies might seem insignificant, they signal a shift in Earth's rotational patterns. For most of Earth's history, the planet's rotation has been gradually slowing due to tidal friction caused by the Moon's gravitational pull. This slowdown has lengthened our days over millions of years. However, the recent acceleration breaks from this expected trend, catching scientists by surprise. The root cause of this phenomenon lies in the relationship between Earth and the Moon. The Moon's gravity doesn't affect Earth's rotation in a simple, constant manner. When the Moon is closer, its gravitational pull is stronger, leading to a slight increase in Earth's rotation speed. Conversely, as the Moon moves farther away, Earth's rotation slows down. This relationship between the Earth and the Moon has been at play for billions of years. In the distant past, when the Moon was much closer to Earth, a day on Earth lasted only about 19 hours. As the Moon moved away over time, Earth's rotation slowed, resulting in the 24-hour cycle we experience today. The recent acceleration suggests that some of the factors influencing Earth's spin are changing in ways that weren't predicted. The Moon's influence on Earth's rotation is complex and not limited to gravitational pull alone. The Moon's gravitational force causes tidal bulges in Earth's oceans, exerting friction on the planet's crust. This friction gradually transfers Earth's rotational energy into heat, slowing down the planet over time. However, this process is not constant. The effect varies depending on the position of the Moon relative to Earth. Earth's rotation can speed up or slow down depending on the Moon's position in its 18.6-year orbit. During certain phases of this cycle, the Moon is closer to Earth, which increases its gravitational influence and speeds up Earth's rotation. Conversely, when the Moon is farther away, its effect weakens, causing Earth to slow down. Recent research suggests that this lunar cycle, along with other factors, is contributing to the acceleration of Earth's rotation. The change in the Moon's position in its orbit has coincided with an increase in Earth's spin rate, and this could be the primary cause of the shortening days. In addition to the Moon's gravitational forces, other factors also influence Earth's rotation. Atmospheric conditions such as shifts in the jet stream and seasonal weather changes can also affect Earth's spin. For example, variations in wind patterns and the distribution of mass on Earth's surface, like the melting of ice caps, can alter the planet's rotational speed. Geological events like earthquakes and volcanic activity can also affect Earth's rotation by shifting the planet's mass. For instance, the 2011 Japan earthquake caused a measurable change in Earth's spin. While the Moon's gravity remains the primary factor, Earth's rotation is influenced by a mix of lunar, atmospheric, and geological forces. While Earth's accelerating rotation doesn't affect daily life, it poses challenges for timekeeping systems. Atomic clocks, which rely on Earth's rotation to stay synchronized with solar time, need adjustments when the rotation deviates from the standard 24-hour cycle. The International Earth Rotation and Reference System Service, ERS, is responsible for monitoring Earth's rotation and ensuring that atomic clocks remain in sync with solar time. To make these adjustments, the ERS occasionally introduces leap seconds, additional seconds added or subtracted from Coordinated Universal Time, UTC. These adjustments are essential to maintaining the alignment between atomic time and the time we experience on Earth. However, as Earth's rotation accelerates, there is a possibility that a negative leap second will be needed. This would involve subtracting a second from UTC to compensate for the planet's faster rotation. This would be a major step as a negative leap second has never been introduced before, and it would require extensive coordination among timekeeping organizations and technology systems worldwide. Even small changes in Earth's rotation can have significant effects on technologies that rely on precise time measurements. GPS, telecommunications, and financial systems all depend on accurate time synchronization. If leap seconds aren't properly accounted for, even minor discrepancies can cause issues, leading to errors in navigation, communication delays, and financial inaccuracies. Earth's accelerating rotation raises important questions about timekeeping. While changes are small now, their growing frequency could lead to long-term challenges. As scientists monitor these shifts, the need for accurate time measurement will become more critical. Understanding the factors behind Earth's changing rotation will help predict future behavior, and humanity will need to adapt with new timekeeping methods and advanced models. Earth's accelerating rotation highlights the complex forces shaping our planet, from the moon's gravity to climate change. While the changes are subtle, they're impacting timekeeping systems that must adapt. Though the effects aren't felt daily, these shifts will influence global systems reliant on precise time measurements. As we monitor these changes, we gain insights into Earth's evolution and the need for science and technology to keep up. Stay updated on these developments. The accelerating rotation of Earth is more than just a scientific curiosity. It's a window into the dynamic interplay of natural forces acting on our planet over time. As we look ahead, the significance of these seemingly minute changes becomes more apparent, not just for timekeeping, but for our understanding of planetary systems, satellite navigation, and even climate modeling. The Earth is not a static entity. It's a complex, ever-changing sphere influenced by countless variables. The spin of our planet, something we once believed was relatively constant, is now proving to be far more variable than we thought. One of the most intriguing aspects of Earth's changing rotation is how it could affect future astronomical observations and space missions. Telescopes, both ground-based and space-based, rely on precise timing and positioning. If Earth's rotation shifts unpredictably, even by milliseconds, it could introduce challenges in calibrating instruments, synchronizing satellite systems, or even aiming deep space missions with pinpoint accuracy. Over long periods, these small errors can accumulate and lead to noticeable discrepancies. This means mission planners, astronomers, and aerospace engineers may have to account for Earth's subtle but accelerating rotation when designing future projects. The implications stretch even further. Consider climate models. These systems simulate Earth's weather patterns, ocean currents, and long-term climate projections. Many of them are sensitive to the Earth's rotational speed, which influences Coriolis forces that shape the direction of wind and ocean currents. If Earth's spin rate continues to change, we may need to revise our climate simulations to ensure they're accounting for these dynamic variables accurately. This is especially important as we confront global challenges like sea level rise, changing weather patterns, and the increasing frequency of extreme events. In addition to technical systems and climate forecasting, there's a broader philosophical question that arises from this phenomenon. What else do we assume to be constant that may, in fact, be shifting beneath our feet? Our understanding of time, for instance, has long been anchored to the Earth's rotation. A day has always meant 24 hours, or so we thought. But now, with scientific evidence showing that even this foundational measurement can change, it forces us to confront the fluidity of systems we believe to be unchangeable. This is a humbling reminder of how much more there is to learn about the planet we call home. Interestingly, historical records show that this isn't the first time humanity has had to adjust its timekeeping to match Earth's changes. Ancient civilizations used sundials and celestial observations to track time, and they, too, noticed the irregularities in solar movements across the sky. Some cultures even developed complex calendars to reconcile the inconsistencies. Today, we're just continuing that legacy. Only now, our tools are more sophisticated, our measurements more precise, and our models more complex. The challenge remains the same: to align human systems with the rhythms of the natural world. Looking forward, one area of research gaining momentum is the study of how the Earth's core dynamics influence rotation. Deep beneath the surface, the Earth's liquid outer core and solid inner core are in constant motion. These movements can subtly shift mass and angular momentum, contributing to changes in the planet's spin. Seismologists and geophysicists are working on models that link core behavior to observable changes in Earth's rotation. If we can unlock this connection, we may be able to predict rotational changes years, or even decades, in advance, giving humanity a powerful new tool for planning and adaptation. Another emerging field related to this phenomenon is geodesy, the science of measuring and understanding Earth's geometric shape, orientation in space, and gravitational field. Geodesists use satellite systems, lasers, and atomic clocks to track even the smallest fluctuations in Earth's rotation. These measurements allow for more accurate positioning, improved GPS services, and refined climate models. As Earth's spin continues to shift, geodesy will become increasingly vital for maintaining the accuracy of the global infrastructure we rely on. Moreover, this research has ripple effects into other planetary sciences. By studying Earth's changing rotation, scientists can gain insight into the rotational behaviors of other celestial bodies, like Mars, Venus, and exoplanets orbiting distant stars. Many of these worlds exhibit variations in spin rates, tidal locking, or axial tilts, and understanding Earth's dynamics helps build universal models that can be applied across the cosmos. In essence, Earth becomes a laboratory for understanding planetary mechanics on a broader scale. From an educational perspective, this discovery is also reshaping how science is taught and communicated. Students today are learning that even something as fundamental as a day is not a fixed value, but a variable influenced by a complex web of forces. This makes science more exciting, more dynamic, and more reflective of reality. It sparks curiosity, encourages critical thinking, and demonstrates how new observations can overturn long-held assumptions. In a world where misinformation often spreads faster than facts, grounding people in scientific literacy is more important than ever. We must also consider the social and policy implications. As timekeeping systems adapt, international coordination becomes crucial. Organizations like the International Telecommunication Union and the International Bureau of Weights and Measures must collaborate to determine how to implement changes like negative leap seconds. Governments and industries need to stay informed and responsive to these changes to prevent technological disruptions. This is particularly important for countries reliant on global positioning systems, digital finance, and satellite communications, all of which could be affected by improper synchronization. Some researchers are also examining whether these changes could be indicators of broader transformations in Earth's internal structure or climatic systems. Could shifting rotational speeds be a sign of redistribution of mass due to ice melting in Greenland or Antarctica? Or might it reflect deeper changes in Earth's mantle and core? While definitive answers are still years away, these questions are pushing science in new and exciting directions. Public awareness is another key component. As citizens become more informed about changes in Earth's rotation and their consequences, they're better equipped to understand why these scientific efforts matter. It empowers people to appreciate the value of precision, collaboration, and continued investment in Earth science. This awareness could also help build broader support for missions, funding, and education in STEM fields. Finally, there's a poetic dimension to all of this. For millennia, humans have watched the skies, tracking the sun's arc across the heavens, building entire civilizations around the rhythms of day and night. And now, we learn that even this rhythm, the heartbeat of our planet, is changing. The Earth, alive with motion, continues to surprise us. Its story is not finished. It evolves, spins, and carries us through space on a journey full of mystery and discovery. As we continue to monitor Earth's spin, we are reminded of our place in the universe, not as masters, but as observers and participants in a cosmic dance. It teaches us humility and awe. It pushes the boundaries of science and inspires the next generation of explorers. The Earth's faster rotation is not just a number on a chart. It's a call to look closer, ask deeper questions, and keep reaching for the stars. Stay curious, stay informed, and stay aligned with the pulse of a planet that is never truly still. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.